Hey there, sixth grade. This next lesson, we're going to take a look at how to solve two-step equations. Previously, we were looking at one-step equations, and so now we'll get a little bit more complex than that. So one-step equations, the reason we call them one-step is because they only involve one operation. Two-step equations, similarly, involve two operations. The goal when solving two-step equations is still the same as one-step. We want to isolate the variable. Remember, isolate means get the variable by itself using our inverse operations. When we are solving a two-step equation, we use the reverse order from order of operations. And so here's what that means for equations. For two-step equations, we undo addition and subtraction before we undo multiplication and division. When you're doing order of operations, remember PEMDAS, we always do multiplication and division before addition and subtraction. Well, when solving equations, we're reversing everything, so addition and subtraction get reversed before multiplication and division. There is one exception to this rule here, and you'll see that on the back side of the notes. So if we jump down to example 1, you'll see we have the equation 2x plus 3 equals 15. And so our goal again is to get this x here by itself. And I have two operations in this equation. I have both multiplication, because I have 2 times x, and I also have addition, the plus 3. Well, according to my rule up here, I need to undo addition before multiplication. So the first thing I'm going to do on this equation is I'm going to use the inverse of addition, which is subtraction, and subtract 3 from both sides. I subtract it once from the left side, and notice how I'm lining it up directly underneath my plus 3 here, and then once from the right side. So these 3's here cancel, and then on the left side of the equation, I have a 2x that I can just bring down. I line up my equal signs, and 15 minus 3 I know is 12. So that's the first step to solving this two-step equation, is to subtract 3 from both sides. My second step will now be to undo my multiplication. Now that this is just a multiplication equation, I can use division to get rid of this 2 here and divide both sides by 2. And so I get x equals 6. Your checks become even more important when you're doing two-step equations. So let's look at the check for this one. To check this, I'm going to take my original equation, 2 times x, and I know x is 6 now. So I'll substitute a 6 in for my x, plus 3 equals 15. Now to do the check here on the left side, I'm just going to follow my order of operations. So 2 times 6 I know is 12, and 12 plus 3 just so happens to be 15. So this does check out. Okay, number 2, I have the equation 5 equals t over 2 minus 3. Again, we undo addition and subtraction before multiplication and division. So I see subtraction here. On the right side, I want to undo that by adding 3. Once on the right side, and then also once over here on the left side. So I bring down my equal sign. On the left side, I have 5 plus 3, which is 8. And then on the right side, my 3's cancel, and I'm left with t over 2, or t divided by 2. So now I have a division equation, and I get rid of division by multiplying. I want to multiply both sides by my denominator 2. So multiply here and multiply here. On the left side, 2 times 8 is 16. And on the right side, my denominator 2 will cancel with this 2, and I'm left with t. So I get t equals 16. Again, to check this, I have 5 equals t, which is 16 now. So 5 equals 16 divided by 2 minus 3. If I do order of operations on the right side, I do the division first. So 16 divided by 2 is 8. So I get 5 equals 8 minus 3. And 8 minus 3 is indeed 5. So that checks out. Okay, 3 and 4 are on your own equations, so what I want you to do for those is I want you to pause the video, and I want you to try solving each of those on your own. Also do the checks to see if you're correct, and then once you've done both 3 and 4 on your own, click play to check your answers. Okay, so here is the work for 3 and 4. Be sure you're checking your answers, making sure you have all this work on your notes. So for number 3, you should have gotten the solution y equals 5. We add 3 first on both sides to get the equation 10 equals 2y, and then we need to divide both sides by 2 to get y equals 5. Here's how your check should look for number 3. Number 4, x equals 243. So first we add 15 to both sides to undo the subtraction, and then we get x divided by 9 equals 27, and then we have to multiply both sides by 9 to undo the division. So if you divided by 9 because you thought 27 divided by 9 is 3, make sure you fix that. You have to multiply here, and so 27 times 9 is actually 243. Okay, so if you have those correct, go ahead and go to the back side now, and we're going to talk about a couple of problems that are sort of exceptions to the rule we had in the front. So when one side of an equation is a fraction with more than one term in the numerator, and here's what I mean by that phrase term. Okay, if I have a numerator that has a sum or a difference in it, then that would be what's called two terms. Okay, so let's look down here at this equation here. See how I have an x and a minus 15 in that numerator? The x itself is one term, and then the 15 itself is a second term. Whenever you have this case, it's easier to undo division first. And again, we undo division by multiplying each side of the equation by the denominator. So do you notice the difference between these two equations? In this equation, we have x divided by 9, subtract 15 equals 12. In this equation, we have x minus 15 all divided by 9 equals 12. Something like the first equation, you do what we did on the front side. You would add 15 first, then you would multiply by 9. In this equation here, because the entire left side is a fraction, the first thing we do is we multiply by 9, and then after we multiply by 9, we add 15. So these equations here mean different things, okay? So make sure you know the difference on those. So for number 5, I have an equation like the second one up here. I have x minus 7 all divided by 3 equals 12. So when I see an equation like this, again, the first thing I undo is division. So I'm going to multiply the left side and the right side by my denominator, which is 3. So on the left side, when I multiply by 3, my 3's cancel, and I'm just left with what's in the numerator, which is x minus 7. On the right side, 12 times 3 gives me 36. So I get the equation x minus 7 equals 36. And now I can undo the subtraction with addition. So I can add 7 here and add 7 here, and I get x equals 43. Okay, to check that, I need to substitute a 43 in for x. So I have the equation 43 minus 7 all divided by 3 equals 12. When I do my order of operations here, because 43 minus 7 is all in the numerator, think about it as having invisible parentheses around those. We actually do that first when we do the order of operations. 43 minus 7 is 36. And then 36 divided by 3 is 12. So that checks out. Okay, number 6, similar problem. We have 6 equals x plus 2 all divided by 4. So I undo my division first to get rid of this 4. And so on the left side, 4 times 6 is 24. On the right side, my 4's cancel, and I'm left with the numerator x plus 2. So now I can solve by subtracting 2 from both sides, and I get 22 equals x. Here's how my check looks. I have the equation 6 equals 22, plus 2 all over 4. In the numerator, 22 plus 2 is 24. And 24 divided by 4 is 6. Okay, our last problem is a word problem. And so it says, at the local fun center, a hamburger meal costs $4.50 and each ride costs $2.50. If you have $22, how many rides can you go on if you buy a meal? So again, with our word problems here, we always start with a let statement, and the question's asking how many rides can we go on. So we could let R equal the number of rides. Okay, so let's think about this problem. Okay, we have a total of $22 to spend. So I'm going to put that total on one side of my equation, okay, because that's the total amount of money I have to spend. Well, spending this money, okay, if I buy a hamburger meal, first of all, that's going to cost me $4.50. So on the left side of my equation, I'm going to put what I'm buying. I'm buying a hamburger meal for $4.50. And then I also am paying $2.50 for each ride. Anytime you see that word each or per in a word problem, remember it usually means multiply. So it's $2.50 per ride. I'm going on R number of rides. That's what I'm trying to figure out. So I'm adding to the $4.50 I'm spending 2.5 times R. Okay, 2.5 times R. So that's the equation that's going to allow me to figure out how many rides I need to go on. So now to solve that equation, I need to undo subtraction first, so I can subtract 4.5 from both sides. Off to the side here, 22 minus 4.5, we'll have to work with decimals here. We get 17.5. So we get 2.5R equals 17.5 as the next line in our equation. And now to get R by itself, I can divide both sides by 2.5. So R is going to be equal to whatever 17.5 divided by 2.5 is. So now I can do some long division. I need to move my decimal point over 1, remember, on each, both the dividend and the divisor. And 25 will go into 175 7 whole times. 7 times 25 should give me 175. So that means that R is equal to 7. And because it's a word problem, again, we want to put our answer in a sentence with labels. We can say, you can go on 7 rides. Okay, as always, if you have any questions on this video, be sure to ask those the next time I see you. And until then, have a nice day. You're all wonderful people.